In this lecture, we will explore the concept of encapsulation in Python. We'll cover the different types of attributes, including public, protected, and private, and discuss how encapsulation helps to safeguard our data. We'll also dive into getter and setter methods, and how we can use the property decorator to make our code cleaner. By the end of this lecture, you'll see how encapsulation improves the structure and integrity of our code. Encapsulation is one of the main pillars of object-oriented programming. It's all about bundling data or attributes and the methods that operate on that data into a single unit, usually a class. With encapsulation, we can hide the internal state of objects from the outside, controlling how it's accessed and modified. This is especially useful for maintaining the integrity of our data. Now, let's dive into how we handle different types of attributes in Python. In Python, naming conventions help us distinguish between public, protected, and private attributes, signaling how they should be accessed and used within our code. These conventions are more about guiding developers than strictly enforcing rules. Let's create a new Python file in our class folder called encapsulationexample.py to practice these concepts. Inside this file, we'll define a simple person class. Here's what we're doing in this code. First, we define a person class with an init method, which initializes three attributes: name, age, and salary. Self.name is a public attribute. It doesn't have any underscores before its name, which means it can be freely accessed and modified from outside the class. Self.age is a protected attribute. The single underscore before the name is a convention in Python. It's a way of saying, this attribute is intended for internal use only within the class and its subclasses. However, this is not a strict rule. Python does not prevent us from accessing or modifying age from outside the class. It's more like a warning label for other developers telling them to be cautious. Self.salary is a private attribute indicated by double underscores. This is meant to be hidden from outside access, even from subclasses. If we run this code, nothing is printed out yet, as we're just defining the class. To see this in action, let's create an instance of person and try to access these attributes. When we run this code, we observe we can access name directly because it's a public attribute. We can also access age directly, even though it's marked as protected. This is because the single underscore is just a convention. It doesn't strictly restrict access. We get an attribute error when trying to access salary because double underscores make it a private attribute. This is due to Python's name mangling mechanism. To sum up, the single underscore suggests a convention to developers that certain attributes are protected and meant for internal use. In contrast, double underscores actually restrict access by using name mangling, making it harder to access private attributes from outside the class. By using double underscores, Python applies a process called name mangling. This means that Python automatically changes the name of the attribute to include the class name as a prefix. For example, if we have an attribute named salary in a class called person, Python internally changes this name to person salary. This makes it much harder to access the attribute directly from outside the class because the original name salary is no longer used. This name mangling helps protect the attribute and avoid accidental access or modification from outside the class. However, it's still possible to access the attribute if we know the mangled name, but it requires an intentional effort to do so. Let's try it out just for fun. I'll comment out this problematic line to allow the code to run to the end without interruption. If we run the script again, we will see that it now prints the salary using the mangled name. While it is technically possible to access the private attribute using its mangled name, doing so goes against the intention of keeping the attribute private. This is why accessing private attributes in this way is not recommended. Instead, to safely access and modify private attributes, we use getter and setter methods. Let's add these methods to our person class. Here's what we're doing now. We added a getSalary method that returns the value of salary. The setSalary method updates the salary value, but only if the provided salary is positive. This adds an extra layer of control, ensuring that the salary cannot be set to an invalid value. Let's use these methods. When we run this code, we should see the salary printed, updated, and then an error message for the invalid input. Using getter and setter methods works well, but there's an even more Pythonic way to handle access to private attributes. In Python, we can use the property decorator to make our code cleaner and more intuitive. Let's update our person class to use this feature. Here, we define a property for salary using the property decorator. We then use the salary.setter decorator to create a setter method for salary. This allows us to access and modify the salary attribute directly using the dot notation, like this. When we want to print person.salary, the getter method is automatically called to retrieve the value of salary. Similarly, when we assign a new value to person.salary, the setter method is triggered to update the salary. This automatic calling of getter and setter happens because of the property decorator. If we run this code, we see a similar output as before. The property decorator lets us access and modify the salary in a more natural way, while still enforcing our control over its changes. To summarize, in this lecture, we covered encapsulation and learned how to use public, protected, and private attributes to control access to data. We explored how getter and setter methods allow us to interact with private attributes safely. Then we introduced the property decorator to create a more Pythonic way of handling encapsulated data. This practice not only secures our data, but also makes our code more readable and maintainable.